Welcome to the deep dive. Today we're diving into something I think is really cool, AI efficiency.
Okay.
And there's this new algorithm that has a lot of people talking. It could
Hmm.
be a game changer, and it's all about using, get this, addition
Oh, well,
instead of multiplication to make AI way more energy efficient.
interesting.
And the paper we're looking at is called Addition is All You Need for Energy Efficient Language Models.
Okay.
It's a little mathy, I'll admit, but luckily our expert is here to break it all down.
Yeah, no worries. And, it's interesting. This paper is really timely because
Mm-hmm.
this whole issue of how much energy these large AI models use is becoming a bigger and bigger deal.
Oh yeah, for sure. We're basically talking about AI models that are using the same amount of power as a small city.
It's crazy.
Yeah, so how do they even, how does this paper say we can tackle that?
Well, they've taken a really interesting approach. They're kind of challenging a fundamental assumption, the idea that we need all this complex math, especially multiplication,
Right?
for AI. It turns out those calculations, they're real energy hogs.
Yeah, I can see that. If you're constantly multiplying these massive numbers with tons of decimal places, that's going to take a ton of energy.
It adds up.
It really does. So, but how do you even begin to replace that?
Right. It's not like you could just ignore the math.
Yeah.
So what they've done is they came up with this new algorithm
Mhm.
called L-Mul, and basically they found a way to approximate the results of those complex multiplications
Hmm.
using mostly addition.
Wait, addition. Seriously, that seems like such a simple solution. Is it really that groundbreaking?
That's the thing. It might sound overly simple, but I think that's part of what makes it so clever.
Oh, okay.
They realized that they could use addition, really cleverly, to basically create a shortcut
Oh, okay.
and get similar results with way less energy.
Huh.
They call it linear complexity multiplication, or L-Mul for short.
Elmo. I like it. It's catchy.
Yeah.
Um, but how accurate can it really be, though? Are we talking about a big trade-off in terms of performance?
That's the thing that's really interesting. The accuracy is surprisingly good,
Really?
especially when you consider how much energy it saves.
Okay, so how much are we put it into perspective for me.
So their calculations, and obviously this is theoretical, suggest that we could potentially reduce energy consumption by up to 80%
80%?
just by replacing those complex multiplications with these simpler additions.
Wow. Okay, so this isn't just a thought experiment. They actually put this to the test.
Oh yeah, they tested L-Mul on a whole bunch of AI tasks, and the results were honestly really impressive.
Like what? Give me an example.
So we're talking natural language processing,
It's okay.
visual question answering,
Mm-hmm.
even solving math problems, and it worked.
Hold on. Solving math problems using mostly addition. How does that even work?
So basically it comes down to, like I said, strategically applying this shortcut.
Mm-hmm.
And they found that a lot of the really heavy multiplication stuff happens in this core AI component. It's called the attention mechanism.
Okay, so for those of us who don't speak fluent AI, what exactly is an attention mechanism?
Okay, so think about it like this.
Okay.
When you're reading, you don't pay attention to every single word on the page equally, right?
Right.
You focus on the words that seem important,
Yeah.
the ones that help you understand this sentence.
Yeah.
That's kind of what the attention mechanism does in AI.
Oh, okay.
It helps the AI focus on the most relevant parts of whatever data it's looking at.
Interesting. So they're instead of multiplying to figure out what to focus on,
Right.
they're using this L-Mul thing, this addition shortcut.
Exactly.
And it actually works.
Yeah, for a lot of tasks, it works really well.
Wow, that's wild.
Yeah. And that's what makes this research so cool,
Mm-hmm.
because you can swap out the multiplication for the L-Mul in that attention mechanism,
Mm.
and you see almost no drop in performance for a lot of these tasks.
That's amazing. What does this mean going forward? Are we going to have a whole new generation of AI that's way more energy efficient?
Well, it's still pretty early, but this research, it definitely opens up some exciting possibilities. Imagine running AI models on your phone
Oh, yeah.
or your laptop. They're way more powerful than what we have now, but they don't kill your battery in an hour.
Right.
And think about the data centers. Those things are using a ridiculous amount of energy.
You really are.
So if we can make the AI computations themselves more efficient, that could save a ton of energy.
Yeah, that's huge. We're talking about less strain on the power grid, smaller carbon footprint.
Exactly.
L-Mul is a win-win.
Yeah. It really highlights the potential here for finding creative solutions to this, AI energy problem.
Totally. So where do we go from here? How do we get from this L-Mul idea to something that people are actually using.
So the researchers, they think the best case scenario would be to actually implement L-Mul at the hardware level.
Oh, okay.
So right now they're basically simulating it
Got it.
on existing hardware, which, it works, but it's not as efficient as it could be. Imagine if we had chips that were specifically designed to do L-Mul.
Oh, wow.
That's when things could get really wild.
Purpose-built, just for efficiency.
Exactly.
So is this like a sci-fi dream, or is this something that people are actually working on?
Oh, I'm sure there are hardware developers out there that are already, looking at this really closely.
Yeah.
This L-Mul algorithm, it could be huge. Like GPUs were for AI.
Oh, yeah.
Remember, GPUs were made for graphics.
Right.
And then people realized how good they were at AI stuff. And the rest is history.
That's a good analogy. So we're saying this new algorithm comes along, changes the game for AI hardware.
Yeah, and it shifts the focus, too.
How so?
So instead of just trying to cram in as much power as possible,
Right.
we can start prioritizing efficiency.
Got it. So it's like a totally different way of thinking about it.
Exactly. And that could have huge effects on everything,
Yeah.
from the devices we use every day to those massive data centers.
Okay, so we've talked a lot about the potential here. But for like the average person listening to this,
Yeah.
why should they care about this L-Mul thing? Like, what's the real world impact going to be?
That's a great question. It's easy to get lost in all the technical stuff,
It is.
but you got to remember why this matters. I mean, think about how much we already use AI.
Oh, it's everywhere.
From Netflix recommendations to those voice assistants we're all talking to.
Sure.
And as those AI systems get more complex, they're going to need even more energy.
Which is not good.
Not good. So anything we can do to make them more efficient is going to make a real difference.
Right.
Less strain on the power grid, lower carbon emissions,
Yeah.
maybe even cheaper AI stuff in the long run.
Oh, wow. I like the sound of that.
It's a win-win.
It really is. Yeah, totally. It's like a rising tide lifts all boats or whatever, right?
Exactly. Everybody wins. And I think what's so interesting about this research, about this L-Mul thing, is that it kind of shows you something important about how AI is developed. We tend to think that progress always means like bigger hardware, more powerful hardware.
Yeah, faster, stronger.
Yeah, exactly. But this shows that sometimes the best way forward is to go back to basics.
Right, rethink the fundamentals. So instead of like, I don't know, trying to build a supercomputer the size of a house, maybe we need to be thinking about how to make the building blocks themselves more efficient.
That's a great way to put it. It's like, instead of having this gas-guzzling engine,
Right.
we figure out how to make it electric, streamline it.
Yeah, same function, way less energy.
Exactly. And who knows what other things are out there, right? What other, fundamental tweaks could we make?
Yeah. Are there other basic operations we could swap out to save even more energy?
That's what I'm wondering. I mean, if we can get an 80% reduction just by switching from multiplication to addition, imagine the possibilities.
Right. That's wild.
It really is.
So to everyone listening, if you're working on AI, maybe take a look at those fundamentals.
Yeah, good idea. Question everything.
Because today's crazy idea could be tomorrow's breakthrough.
Absolutely.
And that's what makes this field so exciting. There's always something new to discover. There's always more to learn.
Exactly.
Well, on that note, I think we've done our deep dive for the day.
I think so. This was fun.
It was. Thanks for breaking it all down for us.
Anytime. Always happy to be here.
And to everyone listening, thanks for exploring with us. This has been The Deep Dive.